Welcome to Infrastructure and System Monitoring with Splunk and Telegraf. My name is Lance O'Connor. I work for TiVo. This is Nick Tankersley. He works for Splunk. I'm a distinguished engineer at TiVo, principal product manager.
Yeah. So, am I on too? Or are we still working out sound? I think we're still working out. There we go. All right.
Yeah?
All right, good. Hi, everyone. So, my name, as Lance mentioned, my name is Nick Tankersley. I'm a principal product manager at Splunk. I am the product manager on Splunk App for infrastructure, which we'll talk about as a part of Lance's talk on Telegraf Metrics and Splunk.
I'm sure you've seen this already. If not, you're going to see it a lot more for the rest of the week. You can read it when you get a copy of the slides later, I'm sure. Like I said, my name is Lance O'Connor. I'm a distinguished engineer at TiVo. I've been there for most of the last 13 years. I took a small break to help a small South Korean electronics manufacturer do some cloud deployments. I've been focused on Splunk and metrics and monitoring and data science for the last 3 years at TiVo. Previously worked in everything from corporate IT and security to production operations to engineering teams. So I've dealt with all of the problems that we've had to deal with monitoring systems for a very long time. I've traveled all over the US and Europe deploying large-scale systems integrations for TiVo. And besides writing the Splunk Metrics Serializer for Telegraf, I also recently wrote a input to read data off my thermometer so that I can keep better track of the meat on the smoker. So, in Splunk, of course.
Yep, thanks. So as I mentioned, I am the current product manager for Splunk App for infrastructure. I've been at Splunk for 4 years, so if there is an IT product that has been developed by Splunk that's an application, there's a good chance that I've worked on it at some point. So that's everything from the VMware app to the Exchange app to the Unix Linux app, the Windows app, the AWS app. And so I've been working heavily with our engineering teams and our ITSI team to consolidate our app portfolio into really 2 focus areas for us from an IT operations perspective. That's Splunk App for infrastructure, as well as IT service intelligence. I've been one of the earliest adopters in Splunk for metrics and our team's been driving metrics adoption. So if there are several of you here who have not started your metrics journey with Splunk, there will be a Q&A period at the end. Please feel free, all topics are on the table. I do not have a Twitter handle or anything else like that, but I do have an IMDb and some very strange producer credits from about 10 years ago. As I mentioned on my slide, whatever food Lance makes, I eat. So I'm the one who's here to ensure that his integration with Splunk is actually yielding proper results. I'm QA on smoking meats.
And you do a fine job of it.
Thank you very much. I appreciate that.
Okay. Metrics are better than events for time series data. I think it's not a hard topic to grasp, but at the same time, for a long time, all we had were events indexes. And so when we finally got a metrics-based index in Splunk 7, we decided to look at it. And it turns out it came at a really good time for us at TiVo. So event-based monitoring is slow and complex. Searching for raw events takes a long time. You have to go to a lot of buckets. You have to parse the data. You have to try to get the number that you want out of the event. And metrics are just better at storing this data. They're faster. They're smaller. They compress better. They return results faster. They don't even use the same traditional data storage on the indexers that the event-based indexes do. I mentioned it came at a good time for us because TiVo had merged with another company and we got a new set of teammates. And our new set of teammates were used to using Scalar and we were using Splunk. And they were used to point and click interfaces and the ability to quickly draw metric CPU usage charts. And they didn't have to type weird commands like recs and eval and stats. It was all just very easy for them to get to the data that they wanted very quickly. And they wanted time series data because they could take samples quicker. They could take 1, 5, 10-second samples instead of with events-based indexes where we were taking 1, 5, 10-minute samples. And so we acknowledged that we needed to move to metrics to support our teammates. And we just couldn't do that with the Splunk infrastructure that we had using the events-based system. So we used Telegraf. But why Telegraf? Well, they use Telegraf with their Scalar infrastructure, and we use Splunk, As part of being good teammates, we wanted to not just slam all the things that we used down their throats, we wanted to be able to adopt some of the things that they used as well. So since they were using Telegraf, we took their metrics collector and worked with and moved them into our data presentation layers. So the nice thing about Telegraf is it's really versatile. It's got 160 inputs, more than 160 inputs, more than 20 parsers, processors, aggregators, and serializers, which is kind of how it manages the data internally. 30 different outputs, 11 of which that support the serializers, which change the data format internally before it gets sent to the output. And they build on 25 different platforms every night. They have every operating system that you could potentially want to run this on, you can run Telegraf on. And it's small. It runs on a Raspberry Pi, and it runs on a multi-core server. The way that the architecture is put together is also great. You get lots of inputs that then go into the parser, processor, aggregator line, and then you match serializers to outputs. So with the very modular architecture, it's very easy to get lots of different inputs, whether you want CPU or memory or disk or MySQL data or Kafka data. There's a different input for all of those things. You can then bring it into the internal structures at that point. You can parse the data out differently. You can do processing at the client if you want. If you want to do pre-aggregation at the client level before it gets up to Splunk, you can do that with one of the processors that they have there. In fact, we use one of the processors to rename all the events so that the Splunk App for infrastructure sees it properly as Telegraf-based data. And then the serializer goes to the outputs. Now, when we were originally talking about connecting Telegraf to Splunk, I said what we need is a Splunk output. So I'd never written Go code before. Telegraf's written in Go. Well, I can figure this out. So we went and looked, and we knew we were going to talk to the HTTP event collector. So I went and looked at the HTTP output, and then kind of understood how that was put together. Then we looked at the input data stream, so I understood how it was coming out of the processors, and figured out what we need to do to make it so that it was compatible with the HEC inputs. And then I got that all working. And then I realized that this really isn't the best way for us to do this. We don't only ever want to be able to talk to a HEC. We want to be able to talk to a universal forwarder if we want to. So I threw all that code away, and I rewrote the Splunk Serializer instead of the Splunk Metrics output. The serializer does just like we talked about earlier. It takes the data and it transforms it internally, but then hands it off to the output. This gave us a lot of advantages. We could make the changes that we needed to the data structures so that they were properly processed by the HEC or a universal forwarder monitoring a file. And we could use the standard outputs from Telegraf. We could use the HTTP output. We could use the file output. And I no longer had to maintain HTTP or file writing code. I just had to maintain the data structure changes. So, correctly, we went to metrics indexes because they're just better for the system, for the data that we're trying to collect. Telegraf has a super small footprint that gives us a lot of different options for deploying. TiVo, as you may know, has a lot of embedded devices in lots of homes. We don't necessarily use Telegraf on our set-top boxes, but they do have a binary that could potentially run on those if we wanted to use that to collect data. It's a very small footprint system. It has input plugins for virtually any data that you have, and people are adding new ones every day. And it's also very easy to add one if you have a very special custom implementation that you need. And now with the Splunk Serializer, it talks to Splunk natively. So again, we moved to a serializer because it solved our deployment problems much better. There's several different ways we can deploy Telegraf now that we're using a serializer. We can have a standalone deployment. We can deploy Telegraf on its own. It doesn't require any additional Splunk components to be installed on the system. Very small memory and processor requirements, and it can talk directly to the HEC. So you can put it on you can put it on platforms that Splunk doesn't have binaries for example, collect data off those platforms, still collect those metrics back in your centralized Splunk management system, and not have to worry about whether you're ever going to be able to get a Splunk forwarder to be able to run on that particular platform. And then, like it says here, you can also manage your deployment through whatever IT operations tools you have, whether it's Ansible or Puppet. It's completely decentralized from your Splunk deployment at all. All you need is your HEC token and your HEC endpoint. That's the only thing that needs to be provisioned down to the Telegraf system. Another thing is what we call a sidecar deployment. So Telegraf's installed just like in the standalone deployment, completely separate, managed by whatever IT tools that you want to use, except instead of using a HEC output, it uses a file-based output. Now, in this case, you would have a Splunk Universal Forwarder also sitting on the machines to do things like collect logs and other data that you want to go to your event indexes, for example. And then your Telegraf deployment can write out the metrics data to another file, which the Splunk Universal Forwarder just eats like any other file that it would do, and it sends those back to a metrics index. It allows you to deploy Telegraf using whatever tools that you normally use, and it allows you to manage Splunk however you want to manage Splunk. It keeps them completely separate. Now, the way that at TiVo, the way we deploy this, certainly on our Splunk infrastructure, is a Splunk application deployment. So we've deployed Telegraf as a scripted input. We push down an application from our masters, our distributors, our deployment servers, and they get pushed down to all of the different parts of the Splunk infrastructure. And the first thing it does is it figures out, do I have the Telegraf binary? No, go download it. And then it just runs it, and the Telegraf binary then writes out the metrics data to standard out, which, since this is a scripted input, just gets eaten into the forwarder and forwarded up to the metrics system. So now you can deploy Telegraf using your Splunk infrastructure. And you can have different configs by having different scripted inputs enabled, pointed at different configuration files, for example. And it allows you to manage Telegraf as just another Splunk application, whether it's a TA or any other sort of Splunk application that you would normally deploy from your deployment tiers. So we tried to, when we were doing this, and when we were working with Nick on this, we wanted to make sure that we had a system that would work for everybody, regardless of how they wanted to manage their systems. If IT wanted to manage their infrastructure and they wanted to use Telegraf and they wanted to send it, and they were already sending their output to Scalar, that's fine. Now you just add the Splunk output as well, because you can send the data to multiple places with Telegraf if you need to. If you want to manage it separately, but also use the Universal Forwarder to grab logs off of the same system, then you can use it in that configuration. Or if you just want to use Splunk to manage the whole system, you can do that as well. So, as Nick mentioned, he's been working on Splunk App for infrastructure, so he's going to go over some of the new things about Splunk App for infrastructure that we did with Telegraf.
Great. Thanks so much, Lance. So for those of you who are not familiar with Splunk App for infrastructure, this app was developed and released last year at Conf. We are currently in our 2.0, which was released yesterday, something I'm very excited about. We built Splunk App for infrastructure for a lot of different reasons, but primarily what we were trying to do was bring a consumer-like experience to infrastructure monitoring using Splunk. As Lance mentioned, there are a lot of advantages to metrics. We developed Splunk App for infrastructure specifically to work with metrics and events, but using metrics for what they're good at, which is recording large amounts of time series-based data and recording that within a time series database, and then making it so that users can access that data in a point-and-click interface that has no SPL required. So Splunk App for infrastructure is really there for not our Splunk experts, although it is very versatile and can be used by our Splunk experts, and we have many different customers who are using it at significant scale, tens of thousands of servers. But it's really developed for those team members that you have and those other operational teams that are not using Splunk for a variety of reasons. Either one, they have an existing tool that they feel like is the more comfortable solution, or number two, they don't want to go into a situation where they have to learn the entire world of Splunk and SPL to do things like CPU, memory, and file system monitoring. So Splunk App for infrastructure is built really on a handful of major principles. The first one is that it's all prescriptive. So unlike a lot of solutions in Splunk, Splunk App for infrastructure will walk you specifically through every single data integration, every single data source that we support as part of an add data workflow. This helps you set up things like custom dimensions, which you use for profiling your systems, creating groups of systems that logically group to application, role, service, things like that, as well as give you everything that you need within the UI for setting up your targets of where you will send the data, as well as an easy copy and paste script that you can put directly into a command line that will run download one of our agents, whether that's Universal Forwarder or collectd, which is what we use. Telegraf is an extension on top of Splunk App for Infrastructure, deploys those configurations and begins collecting data without you, the user, really needing to know each of the individual steps. Additionally, we wanted everything to be instantaneous. We didn't want to have to be any other configuration necessary. We didn't want anyone to have to touch a single line of SPL, whether that means whether it means not touching SPL in terms of metric analysis or even log and event-based analytics. So Splunk App for Infrastructure uses data from all the different data sources, all the different data types that you have at your disposal within your infrastructure to create instant observability across your on-prem, cloud, and even now microservice infrastructure. And I'll show a little bit about the integrations that we have in just one moment. But the whole idea here is really giving you, the user, and you and your customers the ability to define their own groups, define their own services, and create a monitoring environment within Splunk that can be up and running in less than a day. So while we have one application, we can do multiple things in an application. We can alert, we can monitor, we can group, we can view host maps. We can dive into troubleshooting workflows. We use logs, as we're seeing in that second picture right there, alongside our metrics. So we can look for profiles, and we can look for different signals that match between our events and our metrics. So you don't even have to jump into another Splunk application or search and reporting in order to do that deep log analysis. It's all right there in the UI for you. And of course, at any moment, you can open any of this in search, save it as a dashboard, or use it within any of your other Splunk applications. Specifically, IT Service Intelligence, which has a tight integration with Splunk App for Infrastructure. So whenever users are ready to move from simple observability and infrastructure monitoring into service-based monitoring, into advanced thresholding, into anomaly detection, all of the content, all of the data that's within App for Infrastructure can be moved to ITSI as well. And we set ourselves up for a very difficult task, but we wanted to ensure that when a problem is reported, whether it comes through a Slack channel, a ServiceNow ticket, or through any other email link, that a user can go immediately into a context-driven troubleshooting scenario so that all of the data that is necessary to find the root cause of a problem is there at their disposal in a point-and-click interface. And as of 2.0, we have extended Splunk App for Infrastructure so that it includes data from Telegraf. So working with Lance and our engineering team for Splunk App for Infrastructure, we identified the data sources and the inputs that Lance recommended and worked through dashboards that he provided. And we built custom content for Telegraf within Splunk App for Infrastructure. So the serializer and the work to deploy Telegraf is still owned and maintained as part of the open source contributions Lance has provided, but the content within Splunk App for Infrastructure was built and is supported by the App for Infrastructure team. And this is the sort of partnerships that we really enjoy here at Splunk, is our ability to identify opportunities to expand beyond where we are currently and to build things that work for not just one customer, but multiple. So when Lance came to us and mentioned that Telegraf was a major data source or a major agent of choice for TiVo, it is something I'd been hearing from other customers for quite a while. So it was a perfect time for us to jump in and begin building custom content within App for Infrastructure so that that data is usable by anybody who has a Telegraf data collection infrastructure. So I'm going to walk you a little bit through the history of App for Infrastructure and where we started and where we are now. And the one thing that I want you to take away from this is that App for Infrastructure is a major investment for us here at Splunk. I mentioned at the top of the talk that we have multiple different applications out there for doing essentially the same thing. We have the Splunk app for Unix, we have the Splunk app for Windows, we have the Splunk app for AWS, we have the Splunk app for Star, right? Those are all things that developed over time. They were all part of our early product portfolio plans here at Splunk. But over the last 2 years, we've decided that it's time to consolidate those use cases. We see more and more teams taking on more and more of the monitoring workload. And so having an app that's specifically for one type of endpoint or one type of data source just wasn't the plan that we wanted to continue moving forward with. We wanted to really put our efforts on ease of use, fast time to value, but as well as a full picture of your infrastructure from every data source we can possibly imagine. So when we launched Splunk App for Infrastructure, we supported a handful of OSs. We didn't even have Windows when this whole thing began. We went with CollectD to start. We did a survey of all the open source agents that were out there. We definitely wanted to go with an open source metric collection agent instead of building one inside of Splunk, which is something that we have done in the past when it came time to collect data. A lot of that is just because the adoption of open source has gone through a huge overhaul from an IT operational perspective, at least from the interviews we were doing at the time. Whereas it used to be sort of a hobbyist thing where a couple of servers had CollectD or StatsD or Telegraf running. We were talking to operational teams that were deploying CollectD as part of their entire orchestration and automation playbooks. So we went with CollectD. It was ubiquitous. It is very lightweight. It is very easy to manage. It has as many of the, I think, inputs as Telegraf. At the time, Telegraf was still a little young, so we went with CollectD, but as we're talking about today, we are actively pursuing those agents that make the biggest impact on you and your customers as well. So we started off with Linux boxes and a little bit of AWS just for a good flavor. We were working with cloud data sources, so we wanted to see that correlation and start build a true hybrid infrastructure monitoring product. But as we got to 1.1, we brought Windows into the mix as well as Mac OS. Although for Mac OS, to be fair, that's mostly demoware. Not a lot of Mac desktop monitoring going on out there. That was mostly our field team saying, like, I need to be able to deploy this on my machine. So we brought Mac OS. It still uses CollectD. The Windows just uses a native UF. So I'm talking a lot about CollectD, but the copy and paste scripts and the easy deployment tools that I mentioned just a few moments ago, those also deploy and update and manage the universal forwarder as well. So the universal forwarder is still a major part of this. It pulls logs, custom configuration data from any one of these different OSs that we're looking at right now. So as we got to 1.2, we added a few more OSs, feedback from our customers, just adding more flavor to this stew that we've been building here in App for Infrastructure. But as we get to 1.4, things get really interesting. And nothing really big happened in 1.3. We won't mention 1.3. But in 1.4, we added support for Kubernetes vanilla, right? Just anything Kubernetes, as well as OpenShift deployments, as well as any Kubernetes running in Azure or within GCP as well. So there is a project out in the open source world called Splunk Connect for Kubernetes. Splunk Connect for Kubernetes can now be deployed and updated via the app for infrastructure. So instead of managing a bunch of YAML files and having to do custom deployments, app for infrastructure can accelerate your time to deploying Splunk Connect for Kubernetes as part of your operational plane for your Kubernetes infrastructure and pulling everything from performance metrics to config maps to container logs to basically any data source you can possibly imagine that's available within Kubernetes. And all of these data sources have content out of the box, so custom dashboards, as well as an analysis view that allows you to pull data, split it, compare it, analyze it, and correlate it visually without ever touching SPL. And as of 2.0, we have added several more sources. Telegraf is the one we are here talking about today, but we also added support for VMware. We also have a Splunk app for VMware. We have an app for everything, and we are beginning to move that data more into Splunk app for infrastructure. The VMware data integration tools are only available currently as part of our ITSI bundle, so any customers currently with ITSI have access to that. The new VMware data collection tools similarly pull performance metrics from your entire vCenter, vSphere infrastructure, as well as ESXi logs, VM logs, configuration, vMotions, things like that, all from the VMware APIs. So again, moving ourselves back into a position where we have one application that does many things that coordinates and collaborates with our premium ITSI application to create a full view and observability across your entire IT infrastructure and all of your services. So I'm going to hand it back over to Lance, and he's going to talk a little bit about how ITSI comes into the picture here.
Thanks, Nick. So you'll notice that Nick got all of the screenshot time. Like I was thinking I should put like screenshots of comp files or something in, but there's really just not much you can do on the metrics collector. Like you get all the fun parts.
Yeah, I did.
Yeah, okay.
Yeah. And I made it that way.
So ITSI 4.2.0, which was released a while ago. We're on 4.3. In fact, 4.4 comes out today. Introduced integrations with Splunk App for Infrastructure. So as Splunk App for Infrastructure detects entities based on data coming into the metrics indexes, they get added as an entity type, which ITSI then can use as its entity infrastructure as well. With Splunk App for Infrastructure 2.0, Telegraf-based entities are also going to be able to be imported directly into your ITSI entity list as part of this integration. So I guess I did get a screenshot.
Yeah.
Yeah. So this was one of our ITSI. This was one of our ITSI nodes, and this actually has a Telegraf node and a collect-D node being monitored in the same way in ITSI. Both of those entities were imported from the Splunk App for Infrastructure integrations. Now, Splunk App for Infrastructure point-and-click interfaces, all very nice. It's very simple. It's easy for people to use. But sometimes you just want to be able to get access to your raw data, and you still need to use the power of SPL in order to draw charts. All this data still goes into metrics indexes. Whether it's because Telegraf is putting it there or you're doing it through Splunk App for Infrastructure, the metrics indexes are still available to you through SPL using MStats and MCatalog and all of the other metrics-based systems. So you see with Telegraf, we get very rich data about not only CPU usage, but also memory charts, so that we know very detailed descriptions about how our memory and CPU is actually being used. This was one of the reasons why we preferred Telegraf over some of the other things that didn't give us as deep of an inspection layer into our system resources. So just to recap, Telegraf Metrics are now recognized for Splunk App for Infrastructure. It was a fun integration. Nick and his engineering team and I got together a couple times and we traded dashboards back and forth. And there's a couple of config changes. There's a couple of config settings you need to set in Telegraf in order for Splunk App for Infrastructure to know that it's a Telegraf data source, and we're going to get those documented soon.
Yeah.
We know what they are. We'll let you know what they are in a more public sense fairly quickly. You just really need to prepend Telegraf dot on all of the metrics, and then Splunk App for Infrastructure knows it. And again, the Telegraf processors have a way to do that.
Yeah, there will be a blog update about all of this post-com. So
yeah.
You're all getting like a sneak preview of something that we put into 2.0.
And then since with the tight integration of Splunk App for Infrastructure and ITSI, you get immediate benefit of being able to see those entities into your ITSI infrastructure. So you can deploy Telegraf easily, or if you already have Telegraf deployed on your infrastructure, you no longer have to try to manage your ITSI entities in a manual way. The Splunk App for Infrastructure will help you do that. And then, of course, you can use your standard SPL for getting access to all this data and drawing whatever charts that you actually need if the point-and-click interfaces don't quite do it for you.
Yep, so a couple of sessions I'd like to call out if you want more information on Splunk App for Infrastructure. We have 2 tomorrow. Unfortunately, it appears like they are the exact same time, so you have to pick, or figure out how to astro project or something like that. So the first one is going to be around the VMware integration. That will be hosted by Ian Torbett, who's a product manager on the SAI team. Ian will be going through all of the current functionality and tools for collecting data from your VMware infrastructure and visualizing that and using that in SAI. And the second one is new releases we have around a beta set of features for multi-cloud. And the multi-cloud stuff is very interesting because we will be using the new Splunk Cloud platform to manage and set up all data collection from AWS and Azure. So this is a TA-less data collection mechanism. There's no reason to run TA AWS or TA Azure if you're using the new beta capabilities. So basically there is a connection between App for Infrastructure and our cloud services that sets up all of the data collection utilities needed to pull, manage, and then make sure that data is coming into Splunk without having to manage a heavy forward or a TA or anything to that end. So it's in beta currently. It's some really exciting stuff. It's also very much showing you where we are going with data collection in general. So I advise checking out one of those 2 sessions. I think we're good.
And I think that's it for us. So if you have any questions, we're happy to answer them.
We have 1. Okay.
So metrics sounds awesome. Laying aside the which collection mechanism you use, if if like today we're doing TA NICs and TA Windows, like multi-KV to get that stuff in Splunk, what's the kind of, like if I could do the same collection intervals, is data converting to metrics going to end up being more, or like cost-wise, like distance-wise, that conversion? Am I in the same ballpark? Am I less? Am I more generally?
So I think license-wise, it's going to be a little higher in metrics in the current version, right? You will be saving on storage costs, and you will also be saving on the time it takes to actually render dashboards. So if you think about, say, a 30-day dashboard with 5,000 hosts, it could take anywhere between 3 to 4 minutes in some cases to load for event-based data. For metrics-based data, it takes less than 2 seconds. Right, so a lot of the savings will come right there. So that's in the current version. If we look at where Splunk is going for metrics in 8.0, there will be multi-value metrics that are available. SAI has not done the work to convert the current data payloads to multi-metrics, but once you get to multi-metrics, you will see a reduction in the amount of ingest that you have from these data sources, right? So TA NICs, TA Windows, both of those inputs will still in the event world be a little lower in cost, but again, a little bit more expensive down the road. But as we move to multi-metrics within Splunk Metrics backend as well as SAI, then that will go down. So for anybody who's unfamiliar, every single metric that's recorded, say CPU active for CPU 1, that's a metric payload, right? And then you'd have CPU steal for CPU 1 and CPU idle for CPU 1. Each one of those are separate metric payloads. In the newest version of metrics, you can take CPU 1 and every single measurement that applies to CPU 1 will come in as a single payload. So in some cases, for some of those inputs, you'll be reducing your payloads by 10 times, 15 times in some cases. It's also important to explain a little bit how metric pricing works. So metric pricing wasn't, when it was first released in 7.0, it was flat rated at 150 bytes per measurement, right, per event they came across. As of 7.2.6, which I think is what we backported the update to, ingest is measured at a ceiling of 150 bytes. So it free floats below that. So if it's significantly less than 150 bytes per measurement, you'll only get charged for that. So some of the measurements we're looking at, depending on the number of dimensions you have, which is metadata on the measurement itself, some of those can be as low as like 1 or 2 bytes. So, it really depends on how much metadata you add to it. But as we get to multi-metric, you'll definitely see a huge improvement, not just in ingest costs, but also storage. Yeah.
Yes. Hold on.
Oh, sorry. Oh, sorry, go. We'll go here and then we'll go there. Yeah. I'm sorry, I couldn't hear the last part of it, so. We have not done any work with Nutanix right now to form that integration. It's strictly VMware, but that's something, Nutanix is one of our big partners, so we can definitely look into. Certainly ITSI could do that. If you can get the data into Splunk, ITSI can use it. App for infrastructure is purposefully locked down. We wanted to make it very easy to use. But it's definitely something that we'll talk to the Nutanix team to see if it's there. We will be looking next year to make SAI, app for infrastructure, more extendable. So if you have custom data sources, you can create profiles that would allow you to use that data within app for infrastructure. But currently, the answer is we're not quite there yet. Yeah.
Okay.
Yep.
Is it possible to store string data, like not only integer, but as a metric?
So a metric's value has to be it has to be a number, has to be an int, has to be a float. Dimensions can be string data.
Yeah.
So effectively, titles and dimensions are strings, but the value is a number.
Yeah. So all metrics need a metric name, a metric value, a timestamp, and a host value. Those 4 things. And then you can have arbitrary number of dimensions. It's not the most optimal way to deal with unstructured data. So it's really designed to be time series based data for measurements.
Yeah, but influx, for example, allows for string data.
Yeah. Yeah, you can definitely do it, right? And I do know we have some internal teams that have done it before. It's just not our recommended way to use that index. Yeah.
Yes.
You touched on it a little bit, but I'm curious what led you to Telegraf as opposed to collect the
Sure. The biggest driver for us was that we had a new set of teammates, and they had a large Telegraf deployment. I mean, there was inertia there already, and so we decided to, while we wanted to look at how successful they were with Telegraf and how we could also use it, getting it to work with Splunk, we decided that we were going to invest some amount of time, which was a weekend at home one weekend, and so it turned out to be simple enough to actually do that, and it allowed us to foster goodwill with our new teammates as well, right? So.
I think we're over here first. Yeah, back there.
Yeah. So, are you saying that Telegraf is basically can it be a full replacement for Collect D as far as SAI is concerned, or you need Collect D and Telegraf together to get some of the stuff SAI needs and maybe other metrics?
No, it's a full replacement for Collect D.
Yeah. Yeah. You can use either one. So one thing I will mention is that support for the serializer is open source, right? So within Collect D, if you file a support case against SAI and it's a Collect D problem, we will take the case from an engineering perspective. If it comes via Telegraf, we'll take a look at it for sure, but it likely will be referred back to the open source project and work on it there. Yeah.
And I do watch the open source project for issues that are related to the Splunk Serializer. There haven't been many, so I'm happy about that. Was there a question over here? Yeah, right there.
Yeah, I was just kind of curious. Have you guys heard of anyone using this type of setup to monitor Splunk itself?
We do. Yeah, that's what, I mean, yeah, we monitor our entire Splunk infrastructure with Telegraf.
Okay, so I guess in my perspective, like let's say I want to monitor indexers, rather than using the monitoring console, you're actually sending out to an HEC endpoint and then ingesting that data to anything SAI.
In our case, we have it deployed as a scripted input instead of going through the HEC. But yes, so it sends data back into, we use the Telegraf metric or index as our metrics index name. And yeah, we have access to that data either through SAI or ITSI or SPL.
Yep. And where we've seen it happen too, customers typically don't send it to a HEC endpoint. They'll send it, like if it's a bunch of indexers monitoring indexers, they'll just send it normally to like a UDP port or a TCP, something like that, to pick it up. So the only disadvantage there is that there's some level of indexing work that has to happen in order to get it into the metric index, whereas HEC can send it straight to the metric index, very little overhead on the indexers. But we do see customers using it to monitor Splunk as well.
Okay.
Yeah.
Great. Thank you.
Yeah, and that's an important point. So one thing I want to mention there, and I believe it's an 8.0, but it's one of those things I don't think we quite put up on the big screen, but I'm fairly sure most of, if not all of Splunk's internal performance telemetry is now natively in metrics. If it's not 8.0, it's coming in a future version. So even us internally, we're moving to metrics heavily as a way of analyzing and monitoring Splunk itself.
We'll go here first.
Yeah,
go ahead.
You next.
You mentioned that you're looking to kind of expand SAI's extensibility. Are you looking at like bringing in pre-structured data from other monitoring tools, for example, like a Nagios or SolarWinds, stuff that you can bring in the events?
Yep.
Right, that's easy to bring in the events via like an API call, but then you have to go through the whole rigmarole of then converting that over to a metric.
Yeah, so our extensions that we build and support, it would all be building things out into metrics and events. So we do that splitting up. And part of that is modeling out the data to make sure that it's consistent across the board. A lot of where we're going in the future is going to be just around more infrastructure components, not looking for separate monitoring components. ITSI has integrations for Nagios currently, and I do believe there is what's called content packs in ITSI that will be talked about tomorrow that's being developed for SolarWinds. So the content pack concept will apply to app for infrastructure and ITSI going forward. That's where we're headed with it. But for us, what we build out, we'll do all the modeling of that. We just get requests saying, okay, I have this custom data source. It's not on our roadmap. I can get it in. Can we make that work? We've entertained the idea of using non-metric data as a way of identifying sources and monitoring. It's just the app performs so much better with metrics, so much better. And ITSI is really built for that. Like it renders everything down into KPIs and summaries.
I'm not sure if this is like the right question, but maybe I want to reflect upon it. Like if you already have a Windows Unix data instance, either some connectors to the
So there's two things. So let's say we're going to start collecting metrics today, right now. So for Windows, it's the perfmon inputs that you currently have collecting data. So you would just switch that data over, and it all start going that direction, right? Splunk converts the perfmon metrics into that. The NICS TA data is very difficult to parse into metrics. It requires a lot of indexer overhead to separate everything out. It's one of the reasons why we went with collect D. Also, working with customers, they like that native. They like deploying and managing collect D better than working with TA NICS, which has its own issues. For moving into Unix, Linux data, we would recommend going to collect D or Telegraf and making that from days right now moving forward. Now, as far as going back to all the past data, that can be a little trickier, right? So there's m-event collect and m-collect, which are commands you can run in Splunk that will go through and shape. You can shape the data however you want with SPL, and then you run m-event collect, and it will go through and turn all of that data into metrics, and it will push that data down to the indexers. Another thing that I've seen customers do too is they do a massive CSV export of like the last 30 days worth of metric data with all the dimensions set in their individual columns and rows. Yeah, like that, yeah. But I've seen that happen, right? That gives you a little bit of flexibility to go and clean the data up if anything happens afterwards and then re-import it back in. So those are the two methodologies. Those take more time. Typically what I've seen though is that when we've been working with customers, they start moving a little bit of their infrastructure over, they start getting comfortable with it, and then they move the rest over, and then the historical data doesn't become as big of a concern, yeah.
And you still have your old interfaces to that data. You still have your old dashboards to the event data too for historical context.
Do we have any more questions?
Any more questions?
Got one right there.
Yeah, just wondering if you've had any experience with bringing data, metrics data in from an SNMP agent.
Yeah, so internally within Splunk, within our own IT shop, we've used the collect D plugin for SNMP to pull that data in. We've also started some early work around looking into how we do SNMP more natively, but that requires a polling mechanism. We have a few specialists have done it with Cacti. Typically what happens, you have, again, two methods here. The first one would pull it in and use props and transforms for shaping everything and then putting that into the indexer. The problem with that is that it adds indexer load for every data source coming in. The other method, and I'm gonna get another cringe, is a CSV method, but a fairly large network provider takes something from, what is it? I forget the system that they have. I forget their SNMP polling system, but they dump everything into a giant CSV that's metric shaped, and then they import that on a regular basis as well. Yeah. Yeah, so I've seen it. We don't have anything that we've built yet, but there's definitely multiple ways that I've seen it done, and people are doing it in a production capacity right now.
And certainly we've heard of people using Telegraf to do the SNMP polling and then write the data out through the serializer as well. So,
yeah. Got one way back there.
Which versions of Solaris do you support?
Oh, you can ask me a version support question. Can I catch with you? Let me get with you right after this, and it's going to be on the website. So I'll just show you where it is on the website, because I don't know off the top of my head. Once we got past like 5 OSs and 10 different versions, it just fell apart for me mentally.
One deficiency, you could say, with collect D that I've noticed is that, for like SAI metrics, you have to tell the input to write to EM metrics, right? That index. But we have other people who want to also send metrics, and they want to use collect D as the aggregator, if you will, and send that into a metrics index. But there's no way to kind of separate that. Does Telegraf have a way to separate that type of data? Like, okay, I want my SAI data.
I let you write your data to whatever index name you want.
Okay.
By the way, so do I.
Oh, okay.
You can actually. SAA, you can write to whatever index you want to write to. Now, if you're talking about having a collect D that gets data from multiple different collect Ds, and then that becomes like a aggregate.
Multiple inputs to multiple indexes in
Yeah.
Splunk, right? So I want my SAI stuff going into, SAI metric
Yeah.
or index, and I want my application metrics going into another metrics index.
Yeah.
That's what I'm looking for. One tool that does it all.
And that would be coming from a single agent. So you'd have one agent on one box that's getting getting data. So this is the use cases that we're building around data stream processing. I don't know if
Telegraf does allow you to set different tags at an input level. So you can override what index individual inputs get written out to.
Okay, cool. I didn't know that. Nice. That's why I come to these things.
Yeah, right. All right, we're out of time. Thank you all for coming. We really appreciate it. Please rate this session. And I hope you have a good rest of your conference.